so, I've got, okay, so we're coming back to our friends with the cards. I don't know. Our friends, the cards and the pencils and the markers, I don't know if they're even friends or, but whatever. Okay, so this is, I think, the third video in a series on sorting algorithms. So far, we've looked at bubble sort and selection sort. Okay, so look at those. And the third one we're going to be looking at is insertion sort. So insertion sort is actually more simplistic
than selection,
and it's the selection sort and bubble sort.
Okay, and how does it work?
And they're also very similar to selection sort, although it's not the same. So I'm gonna show you how it works. Okay, so it's basically the same as the selection sort. So we basically take the pen. So we do have this separate idea of our partitions still. The only thing is, instead of moving the smallest one, I'm just gonna remove the one right after the partition. Okay, so we're gonna move the one right after the partition. So we're gonna move this one here. Okay, there we go. Now, this one, what we're going to do, and we're going to insert it wherever is the appropriate place. So we're going to, that's why it's called an insertion sort. So if it's smaller, we place it here. If it's larger, we place it here. So we shove it in here, basically. This one. Okay, so we shove it in here. This one. Okay. There. This one. Okay, it fits in here. This one. Okay, well, of course we go. And then this. Here. This one goes in here, and this one goes in here. It's really simplistic, right? Have you found that simple?
Yeah.
So yeah, you just, and I think it's what you would have come up with if you were asked how can you sort generically sort an array of numbers. You would just obviously just insert each number wherever right? You just insert each number wherever you wherever it fits. It's amazing. Isn't that okay?
But how does it know where it fits?
How does it know where it fits? Well, it basically just, as I done over here, it like browses the cards like this. So basically, you check A. Is it greater? So let's say we're just like the step where we were doing 4 here, right?
Mm-hmm.
So if we're doing 4, basically what we do is we go like this. Does it fit after 8? No. So we put it here. Does it fit in between 7 and 8? No. So we put it here. Does it fit in between 6 and 7? No. So we put it here. Does it fit between 5 and 6? No. So we put it here. Does it fit between 3 and 5? Yes, it does. Mm-hmm. So we put it here.
But that's pretty smart. And you're saying that it's inefficient because it takes forever.
It actually is inefficient. Yeah, so surprisingly, and I find this surprising myself, there are faster sorting algorithms than this, and as we're going to see, we're going to have merge sort or conquer sort or quick sort that are going to actually all be faster than like bubble sort, selection sort, and insertion sort. So they're...
But now you wanted to show insertion sort, how
Yeah.
you code it, right?
Yes, I'm just...
On your little Raspberry
thing.
device. Okay, let's do it.
Okay, so let's do it. So I'm gonna turn on the monitor. Wait, it didn't turn it on?
I think it was on.
Ah, there. Yeah.
Yeah. Are you gonna open a new window?
I think I will.
Then I would shut this one down because I already saved it.
So what I'm gonna do...
You shouldn't have 2 or 3 windows open on this little thing because it can freeze.
So Python 3. I'm using Python 3, by the way, so... okay, so I'm gonna define a function called insertion sort.
I think you should close the other window. Simon? The previous window from the selection thing.
Have I saved it?
Yeah, I have.
Okay.
For you.
So we're gonna define a function.
Can you like bring the window over here? Because it's easier for me to film.
Okay, there you go.
Okay.
What? Okay. So you define a function called insertion sort. And it's going to take in a list. Okay. So we have a function, it will take in a list. Okay, so what we're going to do is we're going to attempt to sort that list with insertion sort. Okay, so we're going to... Actually, I guess it would be good to have that selection sort thing open again.
Okay.
Just for reference, because it's so similar.
All right.
So,
Let's try it. Let's hope it's not gonna freeze.
Hang on. Yeah, and we had 2 windows open before and it didn't freeze, so
That's true.
think, so where was, so I'm gonna just,
Maybe
find
you should just like
put a browser.
do file open here.
Actually, I'm gonna find a browse. So Pi. And I got a thing here. So where did you save it? So you said selection sorting.
That's it.
It opened it in Python 2, by the way. So that's why the
Oh yeah, that's true. That's funny.
yeah. Okay, so we're gonna have this idea of a pass num still. So for pass num in range length of n. Okay, there you go. What we're gonna do is we're gonna set we don't have this idea of minimum anymore, by the way. So right, because we're just looking at the one after. So what we're gonna do is we're gonna say for j, or actually, in this code I called it I, so let's call it I here. So for I in range. Oh, you don't have a second loop. Ah, here we go. So this is kind of like the efficiency of insertion sort. It doesn't really actually have a second loop. Or does it? It actually, sorry, it does, but it's for a different purpose. So what we're gonna do is we're gonna just put the element after pass down plus 1. So I'll still have this loop. So for I in range and instead of going from passing on plus 1 to the length, I don't want to look at everything after the pass num. I want to look at everything before the pass num. So we're gonna instead of looping from pass num plus 1 to length of L, what we're gonna do is we're gonna loop from 0 to, I think we have to still loop until pass num plus 1. Right? Because pass num, right, because the end is not included. And we'll find it if that's a bug. So it's browsing. So if the number before index I minus 1 is less than pass num, I think. Plus 1. L index pass num plus 1. So I minus 1 oh, you want to start at the end. Oh, by the way, and it would also throw an error if we're already at the beginning. So I want to start at the end. So I want to actually start at pass num here. I want to go down to 0. Now I want to go down to -1. It's not going to include that. So yeah, with a step of -1. So if I minus 1, and I also only want to do this check. So it's harder than I thought. In words, it's easier than in on a computer. So if I is less than 1, I could say. then I want to just shove it in there. I'm gonna have to look at the documentation. So I'm gonna, hang on, let me open a browser window.
Shouldn't you do that on the other computer? I'm really afraid it's gonna freeze if you open too many windows on this little thing.
Okay, so let me put in, so what was I trying to do again? I want to insert it somewhere. Python list functions. Python lists tutorials point. Let's actually just go to this. Okay. Oh, delete. Okay, so I want to delete the element in so I want to delete the list element index. What was my index again? Passnum. Sorry, passnum plus 1. I already know what. Oh, I don't want to do plus 1 anywhere. Or do I? We can always like rewrite the code later. So delete it and append it. Extend the sort. I wonder what algorithm Python sort actually uses, or any other language. Reverse, remove, insert. There you go, insert. So I can say L.insert. Things are starting to get starting to get going in. Passnum. L index passnum. Right at the beginning. This is the case that we're already right at the beginning. The index goes first. So it's an offset index. So if I just, so insert it at the beginning, pass num. Aha! Something is wrong here. Because look, if I'm iterating through the list and adding to it at the same time, then you might end up skipping some of them. So, yeah, so I might end up skipping some of them. But the thing is, I'm actually already at the end of this whole thing. So I'm already at the end of this whole thing, so we can actually, yeah. Ignore that. Okay, so otherwise, if there's this like keyword ELIF thing, ELIF. So we got a syntax error there. So I'm gonna actually have to enter this into a new thing. So I'm gonna actually, instead of else if, I'm gonna say ELIF. The equivalent of else if in Python. Yeah, no syntax errors, that's good. Delete. Pass them as well. Oh, actually, I can, no, I can't. So delete L index pass num. And insert index pass num somewhere else. In particular at hang on. This is oh my god, this is very, very hard. Okay, so I minus 1 there might be loads of off by 1 errors here, so you know, I think that's it. What's the chance that this is right? Just to be sure that this is right, what I'm gonna do is I got some code over there. I'm gonna see if I have done everything right there.
On the desktop.
Insertion sort, there you go. Oh, it does it in a completely different way. So, it does it in a completely different way.
But you want to try your way first?
Which I think is more efficient.
Where are you looking it up? Where are you looking it up?
So actually, I think I could actually remove this whole idea of I. I can remove this whole idea of I, so I can...
But I thought it was great to try it your way. Why didn't you?
I don't know why, but...
Okay.
So I think I would do this.
Whose method is it?
Whose method is it? Some kind of person that I
Like,
don't
where are
know.
you looking it up?
Some Medium blog. So,
Okay. We should give a link in the description. Okay.
So, that method is great. So it sets the cursor. But I think I could just say LNXI. And pauses I. Well, that's just a renaming. While. That's not renaming. It's gonna. So pause starts at I. So I don't know. What should we call it? I think we should call it a gap. So we're gonna say gap, and it's currently at I, but that's gonna change later. Now, while the gap, well, if it's greater than 0, because, if you get a negative spot in the array, that would make no sense whatsoever.
Yeah.
And array index that spot -1 is greater than the cursor. So gap -1 is greater than the cursor, which is L index I. Oh, it's past num. It's past num here. Okay, alarmingly, it's past num. Array index pause equals array index pause minus 1. Oh, of course. Okay, so we have to. So L index gap equals L index gap -1 and L index gap array here, L. Index gap -1. Oh, do you know what? I just have to subtract 1 from the position. Of course. So I'm gonna have to say gap is gap -1. Everything totally makes sense here.
Not to me.
And finally, when I go to here, the L index gap equals L index past num. And finally, as always, we're going to return L. There we go. This is our insertion sort function. Okay, so now let's call insertion sort. Print. Oh. There we go. And print insertion sort. Sort of L. What's going on here?
Name N is not defined.
N is not defined. That's interesting. Where did I say N?
Over there. Len N. Range. Can you see it? Yeah.
That should be L. There we go. Actually, oh, do you know what I'm gonna do? Stop selecting. I'm gonna just enter all of this, but put L in here. At least we have got no errors. That's a good sign.
That's an interesting way to sort things.
Okay. So I've clearly done something wrong. Just look at the code and see.
Maybe your original code was better.
Rigorously checking always works.
Okay.
So,
go ahead and check it.
cut. Okay. If you don't know what just happened there, don't worry. I'll explain that in a minute. But first, I know what the bug is in my code. So, basically what I've just done is I have inserted a variable called inserted, which is basically, because, you know, something really crazy happened in my code. And it's this. Because L index gap equals L index gap minus 1. Well, that means that I just overwrote what I actually... Wait, I'm gonna look it up again.
Okay, doesn't matter.
Because, look, it's greater than L index past num. Well, L-index passnum changes here. So I need to save what it was previously. And so that's what I have to do. So I just made a quick variable called inserted, which is just L-index, so the passnum. And so I don't have to say this. I'm gonna actually have to say inserted. And actually also here I need to say inserted. Whoop. Print whatever in this. Sorry for that, mishap. Okay. Print insertion sort of L. Really excited.
It's exactly the same as we got last time, with only the 6s and the 8s.
Oh no, I used a different code. That's why. So I'm gonna just do that again.
Because you didn't save it last time.
This technical mishap will be edited out, I'm sure.
Oh, really? By your editing team? Simon's got a really strong editing team.
No. L equals what? Print whatever else. Print insertion sort L. Now, I have a confession. I came to you from the future. No. Okay, Neva, don't make that joke. That edit that you just remember you saw was actually it's almost like 2 days later now, and so. It took me like a while to like get back hanging on to that thing, and then.
But this is the correct.
But this is the correct code. Because I actually have recorded the end to the video that we did before. But the video that we did before it failed, and I didn't know how to answer it. But now I know how to answer it. This is the new.
Just ask future Simon.
I can't do that. I can't do that. It's actually just editing magic. But anyway.
See you in the next video about merge sort,
which we have actually already done.
And we can tell everybody a secret that one was a success.
Yeah, that one was.
Will be a success. We're predicting.
Yeah, we're predicting. Well,
because future Simon knows everything.
No! Don't do that joke anymore. Don't do that joke anymore. And I've actually already done the next video, so so that's why I know this. However, I haven't made the quick start video yet, which I think is what the video will make next, but will not be the next video because I already made it. But anyway. Okay, see you
Have a good one.
See you in the Mercer video.